Okay, so the easiest way I can explain a conversion from degrees to radians when they're just in a quadrant, like whatever quadrant, but they're in one. The first thing you need to know is 42 would be a quadrant 1 angle. So you're looking for radians to be kind of smaller. As far as 225, that's going to be a quadrant 3 angle. And 120 is a quadrant 2. You always want to keep in mind what quadrant you're in. That's going to be one of the most important questions you ask yourself as we progress through the trig unit. When we go to change these to radians, all you have to do is multiply your degrees by this conversion factor, pi divided by 180. So what you would do is you would take 42 degrees times pi over 180, just like this. And then all you would need to do from here is reduce the fraction. Now, what you're not going to do is type this into the calculator and get a decimal. That's not what we want to do. We want to reduce this fraction by looking for a common factor. So I know that 180 is kind of big, but I can use 42 as a base to see what factors go into 180. For instance, I know 7 times 6 is 42, and I know 6 goes into 180. So I can take both of these and divide by 6. If I divide the top number by 6 and the bottom number by 6, I could potentially get a totally reduced in radian form fraction. So 42 divided by 6 would give me 7 pi. And then on the bottom, 180 divided by 6 would give me 30. Now, 7 and 30 don't have any common factors, so this would be the radian measure that goes with 42 degrees. For 225, I would simply take 225 and multiply by pi over 180 because that's our conversion. When I do that, I'm going to reduce this 225 and this 180. I'm going to reduce those by looking for a common factor. I do know that 5 goes into both of those because one ends in a 5 and one ends in a 0. So if I take 225 and divide by 5, I'll get 45 pi. And on the bottom, 180 divided by 5 is going to give me 36. This makes the number lower so that I can choose better. As far as 45 and 36 go, I believe 9 goes into both of those. So if I divide this one top and bottom by 9, I would end up with, and I'll do that on top here and bottom here, I would end up with 5 pi over, and this is 4. 5 pi over 4. And this one would match with that guy. Okay, so 225 divided by 5 gives me that 45. And then when I divide, what did I do? I saw 45 here, and then I got to do the same thing with the 5 here. That's going to give me 36, and then I look for a common factor again. If you can get one right off the bat, that's awesome. But sometimes you can't. That's not so serious. But you definitely want to make sure that they're in lowest terms. The last one is 120. So what we would want to do is we would want to take 120 times pi over 180. And I would want to divide these by finding a common factor. So one of the things that I notice right away is that they both end in 0. So I can divide by 10 right off the bat. And what that does is cancel the zeros out and leave me with 12 pi over 18. Then I can find a common factor much easier, which I believe is 6. So if you divide top and bottom by 6, I would end up with 2 pi over 3. And this is my final answer. So this is how you convert regular old degrees into radians. Now, what happens if you can't find a common factor? You literally would leave it whatever. So if it was 7 degrees, for instance, last one, and I needed to convert that to radians, I would simply do 7 pi over 180. And since 180 and 7 don't have a common factor, this would be my answer for radians. So the goal is to make sure that when you use your conversion of pi over 180, that you reduce it as best you can for the ones that you can, and the ones that you can't, you just leave it be. All right. we're going to go ahead and we're going to talk about how to convert radians to degrees, and then we'll be done for the day.